So, today we're going to look at something pretty mind-blowing. A new AI model that digs into something we all do every night, sleep, to actually predict our future health. This is the kind of thing that could totally change preventative medicine.
I mean, we all do it, right? Every single night. But for something so familiar, sleep has always been one of biology's biggest mysteries. We know it's crucial, but that deep, complex connection it has to diseases way down the road, that's been almost impossible to figure out. Well, maybe until now.
But imagine for a second, what if you could finally crack that code? What if just one night of sleep held the clues to predict serious health problems years before they happen? It's a pretty intense question, and it's exactly what this research is tackling.
All right, so to really get how this is even possible, we've got to dive into the secrets that are hidden in our sleep.
For decades, the absolute best way to study sleep has been this thing called a polysomnography. Yeah, I know, it's a mouthful. Let's just call it a PSG. Think of it as the ultimate sleep study. It's the gold standard, recording this whole symphony of signals from your body, your brainwaves, your heartbeat, your breathing, muscle tension, just a massive, massive amount of data.
But here's the thing, the huge problem that researchers have been banging their heads against. We've been collecting all this incredibly rich information for years, but we've barely been able to translate it. It's like having a library full of books written in a secret language. The real story of our long-term health has been locked inside. So how in the world do you build a translator for a language you don't understand? Well, researchers think they finally found the key.
And this is where it gets really cool. They developed an AI called SleepFM. And look, this isn't just your run-of-the-mill AI. It's what's called a foundation model. The best way to think about it is like it's an AI that's gone to grad school for a huge general subject. In this case, the universal patterns of human sleep. So it can then apply that knowledge to very specific, very complex tasks.
And when I say grad school, I mean it. We're talking about an insane amount of data. The model was trained on over 500,000 hours of sleep recordings. To put that into perspective for you, that's like someone sleeping for more than 65 years, nonstop.
And look, it's not just about cramming the AI with data. The kind of data is what really matters. This info came from over 65,000 different people from all sorts of backgrounds, different clinics, different lives, and that diversity is absolutely essential for teaching an AI to spot patterns that apply to all of us, not just one specific group. Okay, so it's got this massive library of sleep data, but how does it actually read the books? How does it listen to what our bodies are saying?
The magic word here is multimodal. I know, it sounds super technical, but the idea is actually pretty simple. It means SleepFM doesn't just listen to one instrument in the orchestra at a time. Now, it listens to the entire symphony at once. And, this is the crucial part, it learns how all those different sounds, all those signals, play together.
So you've got, on one hand, the constant electrical chatter from the brain, right? The brain waves that tell us if we're in a deep sleep or just drifting off. And, at the exact same time, it's analyzing the rhythm of your heart, your ECG, looking for tiny, almost invisible patterns in every single beat.
And then it layers on top of that your breathing, how deep, how fast, any little pauses you might have, and even your muscle activity, or maybe the lack of it. You put all of that together and suddenly you have this incredibly detailed, high-definition movie of what's really going on inside you while you're out cold.
And because it's listening to this whole symphony, not just one little piece, SleepFM can do something that honestly sounds like science fiction. It can give us a peek into our own future health. Okay, before I show you the numbers, we need a quick lesson. We're going to be talking about something called the C-index. All you need to know is it's a score from 0.5 to 1.0. 0.5 is basically a coin flip, completely random. 1.0 is a perfect crystal ball. And for context, anything over 0.75 is considered really, really good.
Okay, you ready for this? From just one single night of sleep, SleepFM predicted the future risk of dementia with a C-index of 0.85. That is absolutely incredible. That is a huge signal. But it didn't stop there. For all-cause mortality, that's basically the risk of dying from any cause, it scored a 0.84, again, just from one night's sleep. And when you zoom out and look at the whole picture, the story is just as powerful. Using a similar accuracy metric, it's predicting dementia at 0.87, death at 0.85, and even heart failure at 0.83. This thing is finding clues for some of the most serious conditions we face, clues we've been missing for decades.
So the big question is, okay, these numbers are high, but how good are they really? How do they stack up against what we're already doing? Well, this isn't just a small step up, It's a massive leap. Just look at this table. It's a direct head-to-head comparison. For neurological disorders, if you just use standard stuff like age and gender, you get a score of 0.62. SleepFM jumps all the way at a 0.72. For mental disorders, it goes from 0.66 to 0.74. In every single case, digging into the sleep data adds a huge amount of predictive power.
So what's the bottom line here? First, SleepFM consistently blows the standard models out of the water. Second, the biggest improvements are in those really tough-to-predict neurological conditions. And third, this power comes directly from understanding the deep, hidden patterns in the sleep data itself. And maybe most amazing of all, it works really well even on data from patients it's never seen before, which tells us it's actually learning, not just memorizing.
So what does all this mean for you and me? It points to something pretty exciting. This could be your doctor's next superpower.
I mean, think about it. What this research really opens the door to is a future of non-invasive, truly preventative healthcare. Instead of waiting around for symptoms to show up, we could use the data our bodies are already generating every single night to get an early warning, to see the risks long before a disease actually takes root.
And that leaves us with a really fascinating question to think about. So many of us are already tracking our sleep with watches and rings, right? So how long is it going to be before those little devices on our wrists, powered by an AI like this, can tell us more about our long-term health than our doctor can in an annual checkup?